Welcome friends. In this new video we will see how to find a root of complex numbers. Friend, we are familiar with the exponential form of complex number. If z is a complex number, then z equal to r into e raised to I into theta plus 2k into pi, where k equal to 0 plus or minus 1 plus or minus 2 dash dash dash. This is exponential form of complex number. Here, when we want to find the root of complex number, nth root of complex number, z raised to 1 by n equal to r raised to 1 by n into e raised to I into theta divided by n plus 2k pi divided by n. This is the root of the complex number, nth root of the complex number. Now, when k is equal to 0, 1, 2 up to n minus 1, we get distinct root of the complex number. So, for these values of k, we can find the distinct root of the complex number. So, this is the definition of complex root of the complex number, as z equal to r into e raised to theta plus 2k pi. K is vary from 0 plus minus 1 plus minus 2, that means it is a set of integers, and then nth root of this z equal to r raised to 1 by n e raised to I into theta by n plus 2k pi divided by n. And for k equal to 0 to n minus 1, we get n distinct root of this complex number. So, friend, let us take example to find the root of this complex number. We take example, find all roots of the complex number minus 8i raised to 1 by 3. All values of this. So, this distinct complex root we denote by the symbol Ck equal to nth root of r into e raised to I into theta divided by n plus 2k into pi divided by n, where here k varies from 0 to n minus 1. So, this is the symbol we are going to use here to denote the distinct complex root of this. So, let us find all the values of the minus 8i raised to 1 by 3. So, if we compare this with z is equal to x plus iy, this number minus 8i, then we have x equal to 0 and y equal to minus 8. So, look at this, friend, x is less than 0, x is equal to 0 and y is less than 0. So, obviously here argument of z is equal to minus pi by 2. This is the standard formula to find the argument when x equal to 0 and y is less than 0. Argument of z is a minus pi by 2. Now, here we can see that r is equal to under root of x square plus y square. This is the formula. So, this is equal to under root of x square 0 square or minus 8 whole square. So, this will be under root of 64 and that will be 8. Okay. So, we get here r and theta. Now, let us write this z is equal to, in terms of exponential form, r into e raised to I into theta plus 2k into pi. Substituting the values for this z, Z means minus 8i. So, this is equal to minus 8i. This is what is r into e raised to I into theta. Theta is minus pi divided by 2 plus 2k pi for k is equal to 0 plus minus 1 plus minus 2 dash dash dash. Okay. So, to find the distinct root here, n is equal to 3. So, distinct root are k is equal to 0, k is equal to 1 and k is equal to 2. So, these are the distinct root up to n minus 1 and that distinct root are. So, therefore, minus 8i raised to 1 by 3 is equal to 8 raised to 1 by 3 into e raised to I into minus pi by 2 plus 2k divided by pi whole divided by 3. Okay. So, 8 raised to 1 by 3, this is we get 2 e raised to I into minus pi divided by 6 plus 2k divided by pi divided by 3. Now, let us take C0, we call it as by substituting k is equal to 0. So, we get the first root, this is equal to 2 into e raised to I into minus pi divided by 6 minus pi divided by 6, this is equal to 2 into e raised to, we write it as a cos of minus pi by 6 plus I into sine of minus pi by 6. Okay. So, this is equal to 2 into cos pi by 6, cos pi by 6 is under root 3 divided by 2 minus I into sine pi by 6, sine pi by 6 is 1 divided by 2. Okay. So, taking 2 common and cancel and we get root 3 minus I. This is our first root C0. Now, let us find the second root. To find the second root, we put k is equal to 1 in this expression, C k equal to under root of this is C0 here. Okay. So, let us find C1 equal to 2 into e raised to I into minus pi divided by 6 plus 2 pi divided by 3 equal to 2 into e raised to I into minus pi by 6 plus multiplying by 2 4 pi divided by 6 multiply and divide by 2. So, this is equal to 2 into e raised to I into minus plus 3 pi divided by 6. So, this is nothing but pi by 2, 2 into e raised to I pi by 2 and this is equal to 2 into cos pi by 2 plus I into sin pi by 2, cos pi by 2 0, sin pi by 2 1. So, this will be 2i. Now, let us find one more root of this C2. So, let us find C2. You can see that C2 equal to 2 into e raised to I into minus pi by 6 plus 2 into 2 pi divided by 3. So, 4 by 2 into e raised to I minus pi by 6 plus we need one more 2 multiply and divide by 2. So, 2 into 2 into 2 that will be 8 pi divided by 6 equal to 2 into e raised to I into minus 8 pi and minus pi. So, 7 pi divided by 6. Okay. So, we write it as a 2 into e raised to I into pi plus pi by 6. and this is equal to. So, here you can see that first root of this, here we summarize the roots C0. You can see that what is our C0? C0 equal to root 3 minus I, and C1 equal to 2I. So, let us find this third root. We need some space, so we are deleting this, and let us calculate this. It is equal to 2 into cos of pi plus pi by 6 plus I into sine of pi plus pi by 6, pi plus pi by 6 equal to, you can evaluate this by using sine cos of a plus b and sine of a plus b, or you can directly apply the formula if you know. So, let us see, we apply. If you do not know what is the exact value of this, we can apply the formula, that is cos pi into cos pi by 6 minus sin pi by 6 plus I into, this is sin pi cos pi by 6 plus sin pi by 6 into cos pi. So, this is the formula. You can see that 2 into cos pi means minus 1, 2 into minus 1 into root 3 by 2, sin pi is 0 plus 2 I into, separating again sin pi is 0 into sin pi by 6, that is 1 by 2 into cos pi minus 1. So, 2 and 2 get cancel, here again 2 get cancel, and we get minus 3 minus I. So, this is the third root, C1 and C2 equal to minus 3 minus I. Here these are the three different roots of minus 8I whole raised to 1 by 3. So, let us see one more example to get the clear idea about this. Here find, let me clear this first. Find under root of 3 minus plus I whole raised to 1 by 2. So, here you can see that x equal to root 3, y equal to 1, and this is in positive quadrant, first quadrant, and therefore, argument of z is directly, this is equal to tan inverse of y by x, that is 1 divided by under root of 3, and 1 divided by under root of 3 is again we have pi divided by 6. Directly we calculate, since theta is directly equal to argument of tan inverse of y by x. And to find the r, let us calculate r is equal to under root of x square plus y square equal to under root of 3 square 3 plus 1 equal to under root of 4 and equal to 2. So, z raised to 1 by 2, that is under root of 3 plus I raised to 1 by 2 equal to r raised to 1 by 2 e raised to I into theta by 2 plus 2 k pi divided by 2, right. So, this is equal to 2 raised to 1 by 2 e raised to I into, we have theta. What is theta? Theta is pi by 6. So, pi divided by 12 plus 2 get cancel, and we have k into pi. K is varies from 0 plus or minus 1 plus or minus 2, but distinct root are only 2, distinct roots are only 2, okay, only 2, since here n is equal to 2, so k is equal to 0 and 1. These are the values at for which we get distinct root. So to find the distinct root, let us put k is equal to 0 and we get c0, c0 equal to 2 raised to 1 by 2 e raised to I into pi divided by 12, k equal to 0. Pi divided by 12 is equal to under root of 2 into cos of pi divided by 12 plus I into sine of pi divided by 12. Now friend, to find this pi divided by 12, we need some a little bit exercise, trigonometric exercise. We know that cos of 2 theta equal to 2 cos square theta minus 1 and equal to 1 minus 2 sin square theta. This is the formula. Now from this we have 2 cos square theta equal to cos 2 theta plus 1 and 2 sin square theta equal to 1 minus cos 2 theta. We get this term. Therefore, cos square theta equal to cos 2 theta plus 1 divided by 2 and sin square theta equal to 1 minus cos 2 theta divided by 2. From this we calculate here cos square alpha by 2 equal to cos of theta plus 1 divided by 2 and sin square alpha by 2 equal to 1 minus cos theta divided by 2. Okay. So, let us put here alpha equal to pi by 6. If we put alpha equal to pi by 6, we get cos square pi divided by 12 equal to cos here alpha cos pi by 6 plus 1 divided by 2, cos pi by 6 under root of 3 divided by 2 plus 1 divided by 2, under root of 3. So, this is equal to under root of 3 plus 2 divided by 4. This is cos square pi by 12. Okay. Then cos pi by 12 equal to cos pi divided by 12 equal to under root of 3 plus 2 divided by 4 whole raised to 1 by 2. This is okay. Similarly, sin pi by 2, sin square pi by 2 equal to, so here we delete this part since we are familiar with this formula. Now let us put here sin square pi divided by 12 equal to 1 minus cos of pi divided by 6 divided by 2 equal to 1 minus under root of 3 divided by 2 whole by 2 equal to 2 minus under root of 3 divided by 2, and then sin pi divided by 12 equal to 2 here 4 2 minus under root of 3 divided by 4 whole raised to 1 by 2. So, let us put these values here. Substituting these values, you can see that we get here this is equal to what we get, under root of 3 into cos pi by 2 cos pi by 2 under root of 3 plus 2 whole raised to 1 by 2 divided by, we can take this out of this root. So, we write this as a 2 plus I into 2 minus under root of 3 whole raised to 1 by 2 divided by 2. Okay. So, this 2 and this root 2 get cancel, and we have, as you are familiar with this, I am going to delete this part, and you can see that we get the first root of this here, deleting this part. Okay. So, this root 2 and this 2 taking common, we get root value. So, here this is equal to under root of 3 plus 2 divided by 2 whole part in the 1 by 2, 1 plus I into 2 minus root 3 whole divided by 2 whole raised to 1 by 2. This is C0, and we know, friend, whenever x square is equal to 2, then x is equal to plus or minus under root of 2. So, one root is a plus root and another root is a minus root, and therefore, we have another root C1 is equal to minus C0. So, taking minus of C0, we get the another root of this complex number. So, friend, I hope your idea of this root will be is clear now, and using this method we can calculate the root of the complex number. Thank you friend for watching.